or oblique line or asymptote. Okay? In this case, for example, a function is going to have a slant asymptote if there is no horizontal asymptote. Okay? And there are two different or two new formulas to find it. Why? Because we need to find the slope of that inclined line and the y-intercept of that inclined line. So we need to use limits again to find it, and then we need to use that to find the equation and graph it. Okay? We're going to do an example and see what I mean. Perhaps, it's also a condition, but we'll see that. Okay, to exemplify this, we're going to do number 3 from the activity, 2.5.2, but just to find the slant asymptotes. Okay? Number 3. Well, x squared minus x over x plus 2. So, in this case, if I want to find, if we have a slant asymptote, we need to do the same analysis with the horizontal asymptotes. Okay? So let's start with that. If I want to find horizontal asymptotes for this function, what do I do?
Infinity.
Yeah, find the limit at infinity and at infinity. X approaches infinity and x approaches near to infinity. What do I do then? That's what the horizontal. That's to find if you have horizontal asymptote, okay?
Substitute.
Substitute. Okay, substitute
Infinity over infinity.
for both.
Yes.
And if that happens, what?
Because
We're going to apply the limit, but we're going to divide by x. So x squared divided by x minus x divided by x over x divided by x plus 2 divided by x. And that's equal to?
x minus 1 over 1. No?
Yeah.
X. Everything is equal to x.
Limit x approaches infinity of x minus 1 over 1 plus 2 over x, right?
Yes.
Okay. If I substitute, this one becomes 0, but you have the x still. It doesn't become 0. This is going to be what? Infinity. Minus 1, infinity. Over 1, infinity. So that's the first one. For the other one, you already have the simplified form. You can even skip that step if you want to, because you already have this. But now it has to do with negative infinity. So it's going to be negative infinity as an answer. Okay? So in this case, for the horizontal asymptote, do I have an horizontal asymptote here? No, because I didn't find a value. I only found infinities. So there is no horizontal asymptote. Okay? But if the function doesn't have an horizontal asymptote, there's a possibility that it has an slant asymptote with an extra condition.
If it has a horizontal asymptote, there is no slant.
If there's a horizontal asymptote, there is no slant. But if there is no horizontal asymptote, then perhaps you have a slant. How do you know that? Well, we need to check from the function, like it says there, the degree of the numerator and the degree of the denominator. If the degree of the denominator, that is the highest power, is 1 more than the power of the denominator, then you will have a slant and you need to do the analysis. So in this case, for example, this is degree 2, degree 1 is 1 more. So we're going to check the values to see if I have a slant and what will be it. Is that clear?
Yes.
Okay.
¿Esa regla es always o no?
Yeah, always. Okay. So I know that there's going to be a slant. Now we're going to find it by doing this. The first limit is to find the slope of that asymptote, and the second limit is to find the y-intercept of that. Why? Because the asymptote has that form as a line. You need to find the m, you need to find the b. First, the m. The limit x approaches infinity of, here it says f of x over x. What does that mean? That I'm going to put my function and divide it over x. So it's going to be x squared minus x over x plus 2, all of it divided by x. And simplify or solve it if you can. What do I do? How do I divide the function by x? In this case you may. In this particular example you may. But let's do it as if it wasn't able to be simplified. Okay? Yeah, we're going to apply the reciprocals. X squared minus x over x squared plus 2x. Okay, what did I do? I just multiplied that. Tortilla sandwich. Torta. Okay.
Torta ahogada aquí.
Now what? Now we solve the limit again with the same procedure as with the other one. So it's going to be, evaluate this. What do I have? Yeah. And if that happens, what do I do?
Divided by x squared.
Exactly. X squared divided by x squared minus x over x squared over x squared over x squared plus 2x over x squared. Simplify. 1 minus 1 over x over 1 plus 2 over x. And solve it.
1.
So yeah, 1. What's that 1 about? That's going to be my slope of this line asymptote. dm.
So you have to put it in
Yeah. As a slope, inclination.
the same inclination.
Yes. No, this inclination.
What is it? What would be?
The b is going to be the y-intercept of the line.
So m is slope.
M is the slope and b is the y-intercept.
So M is the X intersection.
No. The m is the slope. Inclination.
What is the b?
The y-intercept. Remember the mx plus b?
Yeah.
So the m is the slope, what b is the y-intercept, we need to find it. Yeah.
Why did you choose to do it with the infinite from the right side, or wasn't it?
Okay, good question. In this case it says x approaches positive and negative infinity. Normally you want to do both directions here. No need to. Just one is enough. Because the answer is going to be the same. Just this one. The positive infinity.
Because the answer is going to be times 0.
No, it's going to be
Fractions are going to turn into 0.
oh yeah, in this case. So it doesn't matter. Okay? Yeah.
You didn't have to divide it over x also? Or what? No, but in the m, it also was the function over an x. So you don't have to do it.
We did.
Oh, there's
Function over.
something like.
Okay, now to find the b. To find the b, it's going to be the limit x approaches infinity. It says f of x minus mx is the function
Yes.
over x plus 2 minus m. What m? This one.
1.
So 1x. Yeah,
Why does it keep you 1?
because you just substitute. You put the infinity here, this becomes what? 0, this becomes 0, so 1 over 1 is 1.
Mister, but why x is 1?
1 times x.
Ah, okay.
Now what?
So,
What do I do with those two? This one and that one, what do I do? Common denominator. No. What's the common denominator? X plus 2. So it's going to be x squared minus x, and then to find the other one would be? No.
No, x squared.
X squared minus 2x. That's the one. Common denominator, right? So x plus 2, here the denominator is 1. Common denominator, x plus 2. First numerator stays the same. To find the other one, you can just multiply this one by the negative x. Direct.
X2.
pero ¿por qué no?
3x negative over x plus 2. Do you have questions? Okay, so far? Then, substitute. And divide again.
No.
Yeah.
No me lo creo.
Yes, you better be doing it.
¿Y ese paso es necesario poner el infinito entre infinito?
Of course.
Pero is minus 3x, so it would be minus infinity.
It doesn't matter.
Doesn't matter?
The sign doesn't matter. You put minus to fine, as long as you have this over this.
Okay.
And then you continue. So, yes, again. Simplify. Minus 3 over 1 plus 2 over x. So the answer is? This becomes 0. So minus 3. What?
In the step before, we already know that we are going to substitute.
I need to see this. And from here. Maybe you can skip this one, but I want to see this. So you can just tell me that answer is going to be minus 3. That's it. That's B. So I found M. I found B. What's this load? What's the equation of the slant asymptote?
Y equals x minus 3.
Yeah, the slant. Y equal to 1x, just x minus 3. And that's the slant.
Y.
The time, mx plus b. We already have m, which is 1, we have b, which is minus 3.
So now we can use the equation.
We're going to graph it. We're going to graph the slant, and the slant is going to be also one of the asymptotes. For using the equation.
Using that equation, we graph
The slant. Not this one, because for this one I need to more information. That's the normal one. Yes, yeah.
But there is no, the slant is only if you have the horizontal asymptote.
If there is no horizontal asymptote and the degrees is 1 more, you do the analysis. If the answer is asymptote horizontal whatever value you have, then no slant and you do that.
O sea, profe, literal, eso es el slant x menos 3.
Yeah? Not the slant. No. Not the slant. Vertical and the gap. So they don't have to do. Yeah, we'll go to another example and with everything, and you'll see what happens or in what way that affects the graph. But yeah.
El y-intercept ahí es 0, ¿no?
Yeah, for the function, yes. Good.
Pero una duda.
Yes.
separado este tema, pero este semestre tenemos que entregar también la instrucción, o sea, mandarlo. Es que el tercer y cuarto tenemos que mandar una foto o un PDF de todo.
Ah, portafolio. No.
Guardarlos, ¿no? Las actividades.
No, son por tres.
Pero saben que no van a ser educativos.
Claro.
Como debe de ser.
Y vale mucho más. Solo el portafolio se puede.
Pero no,
La presentación
Ya.
This presentation is
Porque
cuando no haya asymptotes.
Good. Any questions?
Si el exponente de numeradores es uno mayor que el abajo.
Entonces siempre el resultado que nos da va a quedar una X.
Generally, yes. Something x plus minus something else.
profe, entonces no importa si por ejemplo digamos X es disjunto sobre X sobre 2, también si se hace o no se hace.
No.
Solamente tiene que ser uno.
Just one more. Now, for example, 4, 3, 5, 4. One more. Good. Before I do another example, do you remember how to graph a line?
Yes.
No.
Yes. Right from. Yes.
You want to do it? Okay. Okay. Mariana is going to explain how to graph that.
No, me dio valor.
No entendí.
So the y-intercept,
Repeat.
you have your y-intercept at -3, so we're going to start here, and since the line goes like this, and the slope is 1/1, so
How do you know it is 1/1?
Acuérdate que era.
because it's x,
Sí, M es la.
Acuérdate que
Ah, ya,
era
sí,
la
sí, era una fracción.
fracción y la otra es el que.
Si fuera un medio sería 1, 2. Ajá, 1. Sí, profe, el numerador es X o Y.
El numerador está ahí.
El numerador es Y.
Como es 1, es 1.
No puedes rise over run.
Pero porque
¿Dónde dice?
uno negativo,
el 1 es positivo, entonces.
Ah, te la van a cargar.
Profe, ¿y en la B? O sea, en la B, primero simplificas y después de valor.
¿qué chavos?
¿Dónde? Supongo que sí está, si no es que el pie de Darío tampoco.
Pero ahí entonces el X-intercept era. ¿Cuál era el X-intercept?
Ah, you did. You're
Con el reloj If you don't have any number, we have x minus x squared.
Yeah.
Fine.
Fine. We're going to do another one, but this one with everything. Okay? With everything. So find the domain, find the intersections, asymptotes, and graph. Okay? Fine. You have the function number 6 is f of x equal to x squared plus 1 over x minus 2. We're going to follow the procedure step by step. So remember, my recommendation is that in the afternoon, when you finish the activity, use the presentation so you can follow what to do step by step. Quiz tomorrow will have 2 exercises. Yes, but you don't need to find everything for each exercise, just certain parts for each function, okay? Because you only have half an hour for the quiz. Like that. Okay, so we have that one. X squared plus 1 over x minus 2. How do I find the domain?
You restriction. You check restriction.
Restrictions.
X is different.
All the real numbers.
All real numbers except 2. Yeah? That's my domain. Next step.
X-intercept.
X-intercept. F of x equal to 0 and isolate x. So it's going to be?
Minus 2 also, no?
No.
Can't be. Espera.
X-intercept. X-intercept.
Entonces así todo.
0 equal to x squared plus 1. So the answer becomes 0.
Square of minus 1.
Negative positive square.
Negative 1 equal to x squared, so x is equal to square root of negative 1. Is that possible?
No.
No, it doesn't exist. That means that there is no x-intercept. Right? Good. Y-intercept.
X es igual a 0.
Y-intercept. X equal to 0. So f of 0. 0 plus 1 over 0 minus 2. So the answer is?
1/2 minus 1.
Negative 1/2. And the point is going to be 0, comma negative 1/2. Listen, I want the intersections as points, please. Something comma 0 or 0 comma the point. Symmetry now. That will be for the next part. Okay so far?
Yes.
Yeah, okay. So, symmetry, not yet. Good plan. Vertical asymptotes and gaps. Remember, you need to check if you have restrictions. And if you have restrictions, check the limit at that restriction. If you have number over 0 as an answer, then that value is a possible vertical asymptote. If it's 0 over 0, then it's possibly a gap. And you follow with different procedures. Remember?
Yes.
Okay, so let's try this one. What's the restriction here? 2. So we check limit at 2.
Number over 0.
Yeah. At x equal to 2, the limit x approaches 2 of the function is going to be, substitute?
5 over 0.
5 over 0. So, if that happens, it's possible of vertical asymptote. The next step then is going to be what?
Check both minus.
Check left, check right. 2 from the left, and 2 from the right. Yeah. So, evaluate again. 5 over 2 from the left, minus 2, so it's 5 over 0 from the left, and the answer is? Minus infinity. The other one, 5 over 2 from the right? Minus 2 equal to 5 over positive infinity. Conclusion. At least one of them was infinity. So the conclusion is that we have vertical asymptote where? Infinity, no. Vertical asymptote at x equal to 2. Not just 2. X equal to 2. Just put 2, then wrong.
So,
And if it's 0 over 0, it's a gap.
Yeah, because I need both. I need both to graph. So if you just put this and conclude, I'll take one step a lot. Yeah, but like that happens only if you have a gap in there. But that's a different analysis. So.
Teacher, we don't have a gap.
Wait. Vertical asymptote 2, x equal to 2. The next step will be, do I have a gap? No.
You only have a gap when you have 0 over 0.
Okay. I only have one restriction, so the restriction should be either a gap or an asymptote. What's an asymptote? That's it, no gap. Okay? Questions?
And if you had a gap, for example, if you had 0 over 0, you have to get from 0 to
A factor and simplify.
so if it is
Value.
in this case, it wouldn't have vertical asymptote.
So, you obtain 0 over 0, in this case no. But if you obtain 0 over 0, then you need to factor or rationalize or whatever applies until you have a value, which is the gap.
Number 6 is the
Okay. Next step.
Horizontal.
Horizontal asymptotes.
divide by x.
Limit x approaches infinity of the function. So, what do I get?
Infinity.
Yeah. So we follow with the procedure. Limit x approaches infinity of x squared. Let's do it directly. Divided by what? Each term. By x. So x squared over x is just x. Plus 1 over x over x over x. 1 minus 2 over x. Evaluate infinity, so this becomes 0, this becomes 0. You have x, so it becomes infinity.
Infinity over 1 infinity.
The other one, the limit, x approaches negative infinity of the function you obtain. But the answer is going to be negative infinity. Conclusion?
It's not because we already know that.
You don't need to do this again, but I want to say this.
Yes. If we already have done that, we only need to limit the infinity.
The evaluation, the substitution, and then directly this, you already have that.
Because we already have that.
Yes, but if you don't put this, okay.
No, yeah. We have to do both.
Huh? Okay? Listen, everyone, again, for the procedure. I skip this step because it's the same thing. So I evaluate mentally. So you need to put me this. Okay? If you forget to put the limit and just give me this as an answer, then it's going to be incomplete. Okay? Yeah.
So if we write it as the lower one, is that incorrect?
No, it's okay. You already have this. So I already have this, so this, if I do it again, it's going to be the same thing. Just evaluate, so I have that.
And
Okay.
also, since the function has one more degree than the denominator, there is a
That's the next part. Okay, can I erase?
yes.
Hay que checar, aunque ya sabemos que tenemos una slant.
Yeah, but I don't know which one, so I need to find it. I know there will be a slant, yeah, but I need to find it. There is no asymptote, no horizontal asymptote, so there will be a slant because the degree denominator is one more than the denominator. So we process this with the process again. Limit x approaches infinity of what? X squared plus 1 over x squared minus 2x. What did I do? I just applied the tortilla rule mentally. I just multiplied the x with the denominator. That's always the case, huh? You can just skip one step if you multiply the x with the denominator, and that's this. And then what? Infinity over infinity. And continue. Limit x approaches infinity of 1 plus 1 over x squared over 1 plus 2 over x. So the answer is
1 plus what?
Yes. Isn't it a minus?
1 minus. Sorry. But the same thing. 1. Do you get that? I skipped some steps, but still, the procedure is fine.
So we will give you 1.
1 is the slope for this one. Is it going to be always 1? No. In this case, it was 1. But not always. No, that's the slope only. That's the slope only. That means that it's going to be x plus minus something, which is the next part. B. Limit x approaches infinity of x squared plus 1 over x minus 2 minus x. And add the fractions. So it's going to be x squared plus 1, x minus 2 minus x squared plus 2x. Get it? Simplify. If I simplify, what do I get?
Infinity over infinity.
No, before that. Simplify. 1 plus 2x over x minus 2. Yeah? Infinity over infinity. One over x plus 2 over 1 minus 2 over x equal to 2 over 1, which is 2. So the slant is slant y equal to x plus 2. Yeah?
Vamos. Y ahora graficar, ¿no?
Yes. Yeah.
We have to put slant equals to the equation.
The equation only. Slant is for you to know the slant. Because instruction in the exam will say find the slant. So answer y equal to x plus 2. That will be fine. Good. Questions? I understand that this seems a little tedious. Well, not a little, a lot. But still, it's not that complicated. Just tedious. I know. Next partial, it will be a little less tedious, but a little more complicated. For the variables. Okay, so just bear with me till then. Yeah.
¿De qué forma es una asymptote? De los, si hay valores o sea, de y que no, o sea, la gráfica no llega, o sea, solamente se grafica el y igual a x más 2 y la gráfica normal.
Will cancel.
y el app.
Will cancel. Okay, let's graph so you can see what happens.
Vamos.
Okay. Let's graph. Okay? And with that we finish. Yeah.
So in the quiz tomorrow, you won't ask us to get everything. You will ask us in each exercise to get a certain.
Yeah, certain things, not everything.
Okay.
And for the more quiz, will we get like problems like from the project or?
No, for the quiz? No.
Oh.
No, that will be for later, next person. Yeah. For that person, but no, not that. The basic application for derivatives will be for the second partial. But we'll see derivatives, normal derivatives before the partial, this partial ends.
So in second partial, we're going to
1, 2 classes. Also, it already has something as an information. So, fine then. Let's graph. Before that, remember, you want to do the graph? First step, x-intercept? No. Y-intercept?
Yes.
Where?
Minus 1/2.
0, minus 1/2. So, here. Next. Vertical asymptote?
X equals to
X equal to 2. So, vertical asymptote here. More practical. But you cancel, sorry. Okay, vertical asymptote, no horizontal asymptote, no gas, slant asymptote. X plus 2. How can I graph x plus 2? Yeah, remember, when you want to graph a line, this is the y-intercept and this is the slope. Y-intercept is at 2. So, at 2, I'm going to put a point for the slant, okay? Or this is the slant. Just as a reference. Then the slope, exactly, is 1, 1. So, 1, 1. Again, it's just a reference for the slant. You have 2 points, and then you graph. Remember how to do it? No.
You will only have a horizontal asymptote and you get a value that is not infinite.
You have a number as an answer.
And if both are positive or negative,
That doesn't matter. As long as you have a value.
And we also have to draw it as an asymptote.
Of course, of course.
Why is that?
Okay then. Fine. Now the last part. How do I do my graph? The graph has to pass through the points that I have. Has to pass through the y-intercept. And doesn't need to cross the asymptotes. At least not the vertical or slant. So, what do? If you want a little hint, use the limits. X approaches 2 from the left, my graph is going towards what? Negative infinity. So it means that the graph is going to get very close to this, but not cross it, pass through the y-intercept, and then go down to the negative infinity. Because before that.
Because from the right it goes to infinity, so it's...
And the slant is precisely that, an asymptote. So that graph is not going to pass through that. Because an asymptote. Because of this.
But in this case, the graph...
Y-intercept and the slope.
But the graph might be like first, because if you go from the left, it goes towards negative, but from the right it goes to infinity.
Finish. Okay. The next part, it says, 2 from the right goes towards what? Infinity. Here there are no points. You can just invent any points here. You have the asymptote, so the graph should be something like this. Why like that? Again, because you have the asymptote, that's a boundary. That's going to be like that. Okay, it's just a sketch, so
We have,
more or less.
when we have slope, we can,
Ah,
Y esto toma en cuenta
why not?
cuando tenemos el
las condiciones. O sea, quiere decir que pendiente va a ser una
A ver, a ver, primero, necesito que ya sepa graficar líneas entonces de mate 2. Nomás para ahorita, también para después. Entonces, les repito, grafiqué la line, grafiqué la vertical. Tengo un punto, debe de cruzar ese punto la gráfica a fuerza. ¿Cómo sé que va así otra vez? ¿Por qué así no para otro lado? Porque aquí ya no hay puntos que crucen. No puedo inventarme yo un punto por acá, no puedo. Aparte, 2 por la izquierda, les repito, 2 por la izquierda va a menos infinito. 2 por la derecha va a infinito. Vayan viendo todo lo que están teniendo ahí, no nomás es de gratis, está ahí por una razón. Tienen que irle pensando. Ok, de que se vayan.
Sí, ya lo entendí.
Mañana, repaso, primero, 20 minutos, primero trabajamos mañana, y luego el quiz media hora. La actividad terminada para mañana, porque la vamos a tocar.
No se sube nada más.
por aquí.